What's going on, data devotees? It's Jameson here. This video is on functions. What are they? What do they do? What are they made of? And also, when we're using them, how do we get more information about the functions that we have access to, that we might be required to use, whether it's a challenge or an assignment or anything like that. So without further ado, let's jump right in. All right, so we're in our studio with a relatively clean slate, and I'm going to go ahead and just press Control, Shift, and N to be able to open up a new untitled script. And I'm going to quickly save that with Control S, and we will call that, in downloads, we'll just call it x.r. Yes, I want to replace it. So, let's talk about functions. Well, R is totally loaded with functions, and just like spreadsheet software like Google Sheets or Microsoft Excel, which also uses functions, or Python, or really any other data science language that you're going to be coding with, functions, in essence, allow you to transform data. So what does that mean? Well, let's take a look at the empty cars data set. And so I've auto-printed it just by simply writing the name of this built-in data set, and I pressed Control and Return. And of course, the magic happening down here in the console is that we print the information that's stored in object empty cars. In other words, 32 vehicles with 11 observations about each of those vehicles, whether it's miles per gallon or cylinder, anything like that. And so one thing, for example, would be a summarizing function. So if we wanted to for example, take the average miles per gallon, we would use function mean. And inside mean, we would input the name of the data set, and we'd also put the variable that we want to extract and also use mean on. So what does that look like? I'll do Control L to clear my console and Control Return, and we can see that the mean MPG, or miles per gallon, that is the fuel economy of the 32 vehicles and empty cars, is around 20 miles per gallon, 20.09 miles per gallon. So we used this function, in effect, to take input data that we decided, hey, we want to transform, and we output a transformation of that data. In this case, it's simply a summary transformation, but we can do many other things with functions, and there is a massive variety, not only in base R, but in the extensions, aka the packages that you can install for R and load and just use all variety of functions in those packages. So again, it is ultimately a transformative tool for your data. Now, it's not always for your data. Some functions can be a bit more meta, if you will. So for example, getwd is a function in which we don't have to specify anything. We just simply run it the way it is. And when we do that, getwd stands for get working directory. And this lets us know what our working directory is. And that's exactly where we saved our script x.r. And so not all functions require data. Another example would be, for example, directory, and that's going to tell us the objects that exist within our working directory, which is quite nice as well. So they're not exactly transformations of data, but they do help us to navigate where we're storing our information, how to be able to manipulate files in specific directories, etc., etc. Those are just a few small examples. So in essence, you can think of, much like Dr. Jesse Lisi of Arizona State's explanation, you can think of these as an oven in which you put raw ingredients, and you might set some other specifications as well. And out of that oven comes your baked data product, or some sort of transformed data cake, data cookies, and this, that, and the other thing, right? So, but let's talk about not only the ingredients that we put inside, aka the data that we use as inputs, but also different specifications like the temperature that we might set for this function oven and things like that. Before we do that, let's go ahead and look at a relatively common function from the readr package. And so we can actually look at read.csv, and if we don't specify what ingredients we want inside, what temperature we want it set at, whether we want it to bake, broil, anything like that, it's going to go ahead and say that it's missing those default specifications, like file, etc. But let's look at this under the hood. And so to do that, I'm going to use the bare function name. In other words, it doesn't use these parentheses that oftentimes follow a function. And this is also true, again, for spreadsheet software. If you're using functions, these will also have these sorts of parentheses as well. Even in SQL, structured query language, you have functions that have this sort of syntax or format where they're followed by firstly the function name and then something inside parentheses immediately following them. So again, looking at the bare function name and pressing return, we can actually see the internals of this function. Now this is quite interesting because what does read_CSV do? Well, it's actually just a specialized version of another function inside its internals, and this function happens to be read_delimited. So also a function from the readr package. So we're able to look at the internals of a function and see what's going on there. Really, this is just a very specialized use that makes it convenient to be able to read data in the form of a CSV or a comma-separated value. So how to make a function as well, it could be instructive, could be useful for understanding it. So if we wanted to make my function, it would simply be function, and we would essentially function is going to this function is going to be assigned to object my function, and my function becomes the bare name of this function that we're creating. So if we only want one ingredient in it, x, that is in effect one argument inside that function, we can then control what that function does. So I'm going to go ahead and say that we take whatever's input into x and we're going to multiply it by 2. So actually maybe we can come up with a better name for this. My doubler. So essentially we're going to take anything that goes into my doubler's x argument, and we're going to multiply it by 2, in effect doubling it. So when I run this, now in our environment we have a function saved, and we can see those internals very easily. Again, all the function is doing is taking whatever you put in x. Again, we've created our own oven here, and we've set up how that oven's essentially going to work. And again, we're going to take the value of x and double it. So what happens? Well, with my doubler, the first argument is x, the only argument is x, and if I put 5, well, what is 5 times 2? It's 10. And so, in effect, inside this function, it took the value 5, or x equals 5, and in the internals, it simply multiplied it by 2. And so, now that is our new function, my doubler, and packages are, in essence, completely comprised, packages being extensions for R, they're completely, for the most part, comprised of these customized functions that allow you to do things more conveniently, any sort of data transformation, and also entirely new things that you wouldn't normally be able to do in core or base R, aka vanilla R, right? So that's just an example of creating a function to show you kind of how they work on the inside. And what's more, let's talk about function documentation before we get any more into the ingredients that we put into these function ovens, as well as what we might set the temperature to, whether it's bake, broil, how we want to cook it, etc. And yeah, so if we want to learn more about a function, we can actually use function help, and inside the parentheses for function help, we pass the bare function name. Again, the name of the function without any parentheses. So in the bottom right, in our help pane, pops up the documentation to be able to learn more about this function. So we can see, as we noticed before, that it's read delimited, and that's actually the workhorse function that read CSV is a specialized version of. But also this tells us something about arguments. So for example, we have the first argument being file, the second argument being delim, the third argument being quote, and each of these arguments are things that we put inside of these parentheses. So if we wanted to do read underscore CSV, and I'm going to choose the file iris.csv. First of all, let's see if that works. Yes, it does. And so iris contains 150 different observations of 3 different species of irises, and it tells us their dimensions, like their sepal length and width, their petal length and width, and so on and so forth. So this is the very first argument inside of function read.csv. And this is also aligned in the documentation with the very first argument that's listed here. It's file. So the file that we specify as the first argument is iris.csv. Now we have other arguments that we can use as well. And so in this case, it's telling us column names is the next one. In other words, column names. And so in this case, it's even telling us in these tooltips, if it's true, the first row of the input will be used as the column names and will not be included in the data frame. If it's false, the column names will be generated automatically. So we want this to be true, but what happens, there we preserve the names of the columns themselves. What happens if we call them false? Well, that's where R is going to generate the names of these columns automatically for us. In this case, x1, x2, x3, and a very generic sort of naming like that. And so other arguments might include what to do with NA values. Now there are no NA. NA is a missing value. And so what to do with those? What are the column types? Here we can see that these are all charisma, excuse me. Too much Dungeons and Dragons for me. We can see that these are all characters. And so we can actually specify instead that we want these types to be something like numeric, 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 and then character, and then factor. So we can decide using, again, arguments, what these will be. We can make a more sophisticated use of the read CSV function by specifying these arguments. Now, what happens if we were to, let's go ahead and use true again. What happens if I don't name these specifically? So what happens here, that's okay, that's just a little warning message about this column. What happens here is that there is an implicit order to how functions evaluate the arguments that you put inside of them. That's because the very first, by default, the very first argument that you can put in is file. So if you simply pass a value here, it's the same as explicitly naming this argument as file. And for the second argument that read CSV expects happens to be column names. It takes a true, a false, or you can actually name them manually. In this case, we didn't specify the argument column names explicitly. We did it implicitly simply by saying that the second argument in read CSV always asks us if we want to preserve the column names or not. So in other words, it's just expecting that the first thing that you put in here, if it's unnamed, is ultimately going to be your data set. And the second thing, if unnamed, is ultimately going to be a true, false, or a list of different names for your variables. And that's what it's expecting. So why does this happen then? So if I run this, we get an error. Why? Because we didn't explicitly say what argument we were referring to. And because there's this implicit order this expected order that read CSV kind of has in mind when it comes to these arguments, it's going to assume that true is the file that you're trying to read in. Of course, this is not the name of a file in our directory, and in fact, this is not the proper way to specify a file name. And secondly, the next argument, which should be a true, false, or a vector or a series of different names for the columns, is instead a file name. So it's doing something that's unexpected, and it even corrects this. It says file must be a string, raw vector, or a connection. So by connection, it could be, in fact, we could put a URL instead of the name of this, and we can automatically download from the internet using a URL, for example. So it's because it's out of order, and true should be second if we're not going to name the argument, and iris.csv should be first if we're not going to name the argument. However, we can still name the arguments and not have them in order, and so long as we do that, it will operate as expected. This is because even though these are out of order, they are still being explicitly named by the argument name. In this case, col names equals and file names equals. So that's totally fine. So one other thing is that what happens if we don't use col names? I just deleted it there. There it is. Now it's gone. What happens if we don't use it? Well, does it just mean that there's absolutely no variable names whatsoever? Because that's letting us know if it's true, we keep the variable names. If it's false, we get rid of the variable names and we turn them into more generic x1, x2, x3. And if it's a series of new strings or text values, then we can rename those variables. But what if we don't put anything at all? What happens? Right, so it still preserves the original column names and it uses those. That's because this, by default, is actually true. It wants you to preserve those column names or the first values in the very first row in the CSV. Those are going to become the column names by default, no matter if you specify this as true or you don't specify this argument at all. And why is that? Well, we can even look at the tooltips, and so either true, false, or a character vector of column names, and we can see that is there the default here? Well, maybe we can find that in the documentation. So here we go. This is read to lim. Col names either true or false. If true, if false. Does it tell us that it's a default argument? Well, the point here, no, it doesn't tell us. That's very surprising. The point here is that, in other words, this is the default value that's set is actually true. So if we don't specify it, it already has a true or a false chosen for us or some other specification. We might be able to find that not in the documentation, unless it was in there and I just kind of missed it and got nervous. But if we look at the internals of this, we can see col names equals true. In other words, there is a default value that's already set inside this function. So we didn't find it necessarily in the documentation itself, because this is presumably because this is documentation for read to lim, even though read CSV is in here. Oh, here we go. It does tell us, not necessarily in the argument, but it does tell us in the formal arguments list in the usage section that col names does equal true. So apologies for that. I thought it would kind of explicitly tell us in the tooltips, but it did not. So that all being said, those are default arguments. You can also name arguments explicitly or put them in the right order implicitly. And if you put them out of order, just make sure that you name them, of course. So that's an introduction to functions. I hope you found this helpful. And go ahead and start exploring some. A great way to be able to do that is, for example, if you write out the name of the package if you just installed a package or something like that, follow it by 2 colons, and then simply press tab. Then you can find every single function that exists inside that package. And this is called autocomplete. Other ways to explore functions, I mean, there are a ton of ways, but just on the topic of autocomplete, if we were to do read, now that could be read period CSV or read.csv, or it could be read underscore CSV. We can look at all the different reading functions that exist in R. And again, this is called autocomplete. So again, that's an introduction to functions. Feel free to explore them. I hope you found this helpful, and have a good time transforming data with the massive variety of functions that exist not only in base R, but in all of the packages, the tens of thousands of packages that you can download that expand your ability to use new and exciting functions for your data.